Ladies and gentlemen, welcome to this video series called Math of Machine Learning. In this video series, we will be talking about all the math that is necessary to understand machine learning in very much detail. So we will be not just talking about the general principles or how this is done or this is done in general, but we will be actually diving down deep into the math. This video is just a small introduction to machine learning. So if you know nothing about it, this video is for you. So let's think about what machine learning can do for us. Let's say we have an image, and that image is of a 5. And we know that it's a 5 because we as humans learned what a 5 looks like. But for a computer, this is very difficult to understand. Because if we tell a computer this image looks like a 5, there is no rule that we can give the computer to understand what a 5 is. It could compare this image to a lot of other different images, but as soon as the 5 is a little bit different, depends on how you draw it, it will not be able to understand that this is still a 5 because it's slightly different. And this is the biggest problem that a computer has, that it doesn't have a lot of fixed rules where it can understand that this is a 5 and this is not a 5, but a 6, for example, because they look sometimes very similar. So we can't give the computer a lot of rules to understand that this image is, for example, of a certain number. But what we can do is, first of all, deconstruct this image. And for example, this image contains 28 times 28 pixels. So we have 784 digits, and we can put them in one vector. Because the computer can't work with just images, it always has to deconstruct them. We did that for the computer, and now we can give the computer the X. And we can also tell the computer, like, listen, this image, so this vector, corresponds to the category number 5, and we give it a vector that corresponds to the number 5. For number 0, this vector would look like we have a 0 here, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 transposed, because it also has to be a vector. So what we can do is deconstruct images, put them into vectors, and give also the category of that image and also put it into a vector. And now we have many images deconstructed into vectors, and we call that a training set. So this is the set of images that our computer will learn on, or our machine learning model will learn on, to understand the patterns that are in these images. And we have our target vectors, so that's T. So this is our target vectors. So the computer can see this corresponds to this category, and this input vector corresponds to that category. And based on that, it will find some rules to understand what a 5 looks like, because we can't tell the computer explicitly what a 5 looks like, but the computer can learn what a 5 looks like. So this will be our machine learning algorithm, where we have a function where we give a vector, we give the computer a vector, and we expect a prediction. So it will return something that is also encoded like our vector that we had here. And this function has certain parameters. So it can be a big function, and it has parameters that are determined in training. So this is where the computer will be learning the different patterns that all the images have in common, or better to say, that all images of 5s have in common and images of 6s have in common. And these parameters will be learned. They will be adjusted in such a way that it can predict if a new image is a 0, 1, 2, 3, and so forth. So this is just the first part, because after the computer learned the pattern, it learned those parameters in training that describe this function, we can test new images to see if the computer actually learned something, or it just assigned random variables to random inputs. So this will be called a test set, where we have a set of images where we know the number, and we give it to the computer and see, is it really working good? So this is our test set, and the goal is to see if our model is able to generalize. So the generalization part is, can it perform well on pictures that it never saw before? Because if we, again, just give it the images that it saw in training, it can simply do a simple comparison and it didn't learn everything or anything. So we have to see if it can generalize on new pictures. And this is the most important part in machine learning. Can the model perform good for images or inputs that it never saw before? If we think about the categories of machine learning, if we have the training data and the target vector, so we have an input and output, we call it supervised learning, where we know the target. So this is, for example, image classification. This is an image of a 5, that's the input, and the target is category number 5. So we have a finite, if we have a finite number of categories, this is called classification. If we have to classify one image into given categories, this is a finite set. So we don't have unlimited categories. We call it classification. As soon as we have a continuous target, it's called regression. So for example, if I attend 7 lectures and I tell the computer, hey, I attended 7 lectures, how many points will I get on the exam? This can range from 1 or from 0 to 100. And we have many options that I could score. So I can get a 97 or I get a 51.3. So we have unlimited options because it's a continuous variable, and that's called regression. If we only have training data and no additional labels, we call it unsupervised learning. And this can be, again, broken down into multiple categories. First, we could give all the images to a computer, for example, and tell them find groups that have something similar or have something in common. So this is clustering. We cluster the images together based on whether they have something in common or not. Or we can tell the computer that we want to find the distribution, and this will be, or the probability distribution of the data, and this is called density estimation. If we just want to tell the computer, hey, we want some dimensionality reduction, that we want to, for example, if we have high dimensional data that we can't plot, we can only plot at maximum 3 variables, so X, Y, and Z in the 3D plot. But if we have a image, so if we go back, we have this vector. This is a very high dimensional vector and we can't plot it. So we can do dimensionality reduction. So these are the 3 categories for unsupervised learning, but we also have the last element of machine learning, that is reinforcement learning. And reinforcement learning is just about like playing a game. The goal is to choose the best action from a set of action for a given situation. So you can think about it like balancing a pendulum upside down. The computer can move left or right, but if it moves left, the mass might fall down, and if it moves right, the mass will fall in the opposite direction, but the goal is to balance the mass perfectly. So for a given state that the computer can see, so it sees the position of the pendulum and the velocities, it can tell if the mass has to, if it has to move left or right to balance out this mass. So this is just a simple, very quick introduction into machine learning. We will jump right into the next videos where we will do polynomial curve fitting. Don't take this as the most important video in this series, because this is, again, a very simple introduction. There's way much more to learn here, and we will try to tackle every problem over the next multiple videos. Thank you very much for your attention, and I hope I see you in the next video.